Initialization until 2003, 5 exabytes of data were created. The same amount was created in the last 2 days. Now, as we all know, every AI company in the world at the moment is racing to capture all of that data on the internet. And we've gone from playing a catch-up game 2 years ago when ChatGPT came out, when all these models are going to try to capture all this data to actually teach these language models how to reason, or like teach them how to speak, rather, I should say. And now we're facing a bit more of a battle for that incremental bit of data. Who's going to get the next petabyte, the next gigabyte, the next megabyte of data that appears on the internet? We've had a thesis for a long time now at Grass that with the convergence of a lot of AI models, the differentiation between these models isn't necessarily going to be in the quantity of data, the number of parameters, the number of compute that's gone into them, but rather their ability to capture net new information that's appearing on the internet. And if you think about what's changing in the world and what's not changing in the world, the one thing that's staying constant in the next 5 to 10 years is the fact that new information will always appear on the internet. And in addition to that, AI models will always need new information in order to function properly. Now I have some outdated bar charts here to show everyone. Now everything that's 3 weeks old is outdated in AI world. As many of you know, ChatGPT or OpenAI dropped O1 last week, so they're not on here. But the idea kind of remains the same. This middle benchmark is the only one that O1 really, and the coding one on the right to an extent, are the only ones that O1 really affect. But what we're really trying to show you here is the fact that we're starting to see a certain level of convergence among these models. When 3.5 came out, OpenAI had a 2-year lead on the rest of the industry. And nowadays, it's debatable whether there's a lead, given the fact that all the algorithms that made O1 what it is were actually developed by Google's DeepMind team. And it begs the question that I kind of asked earlier, or at least alluded to. In a world where LLM performance has saturated, models are differentiated by their access to net new knowledge. Now, how do they get that net new knowledge? All right, let's back it up for a moment. Let's talk a bit about Grass and what we're doing here in the first place. And I'm seeing a lot of questions. Sounds like a middle school script. Thanks, Chiba. Seeing a number of questions in the chat asking, what is LCR? We're going to get to that in a second. Now, Grass in the first place, it's this network of millions of nodes that are capable of harnessing any information on the public web. We like to think of it as a way to take back control of the internet. What a number of people don't actually know is if you've downloaded a free app at any point in your life, there's a good chance that the company that made that app has snuck some sort of SDK or other type of software on there that's actually harnessing a bit of your unused internet bandwidth. And you might be wondering, why do they want my bandwidth? Like, don't these companies have tons of bandwidth in the first place? The main reason is your bandwidth actually has an unbiased view of the internet. You're on a residential line that you pay for. And if that company can get access to 1 million different residential lines all over the world, they can actually access any website very quickly in a very unbiased way without getting blocked. Because from the website's perspective, they don't see that it's the website that's downloading their information. They're seeing millions of residential connections. Now, this is already happening to all of us in the first place. And for many years now, for like around 2 decades, we haven't been getting paid for it. And that's the whole point of Grass. And number 3, I just want to shout out this community. Everyone here has been fantastic. And, you know, Grass wouldn't be possible without any of the people here. So just a huge shout out to everyone. Now, we can ask ourselves why Grass matters. I mentioned earlier, you know, all of our bandwidth is already being abused by these huge companies that are using it to scrape the web at scale. Now, that web data doesn't belong to those companies in the first place. And that's something that I'll touch on later. Grass does have, you know, intentions of making sure that every stakeholder in the AI equation is taken seriously. There are serious ethical issues with the way current solutions actually operate. And with the huge demand, like the huge growth and need for data, a lot of these companies have started charging exorbitant amounts for their APIs. And the funny thing is, like, they're charging crazy amounts of money for these APIs when the data that they're hosting doesn't even belong to them in the first place. Like, look at Reddit, for example. They're charging ridiculous sums of money for their users' data. Some of you might not really be familiar with this, but Grass open sourced over 500 million rows of Reddit data that got collected in less than a week, not too long ago. Now, we talk a lot about how these big companies are engaging in evil practices, but it's our belief that they're not really evil. It's just that the right incentives didn't exist for them at the time. And they were forced to just do, they were forced along the path of least resistance. And they didn't have the tools to properly reward the people that they were actually extracting value from. And I really love this example here. These are transcripts, or rather excerpts from the Google antitrust hearings. The first one is part of Google's original mission statement. Let me read it out for you guys, because it actually sounds a lot like what a lot of Web3 companies are doing these days. The growth of the open web is at risk. More and more content is being published, consumed, and monetized inside walled gardens, primarily driven by a great content discovery and consumption experience offered there. This poses a challenge to Google's mission to organize the world's information and make it universally accessible. Now, fast forward a few years, and you start seeing excerpts of emails where they're saying things like people's search, their current and past location, their Chrome sync, Android usage, YouTube data are particularly attractive due to their high user coverage. This is not a company that set out to be evil. It's a company that was forced to do evil things because the tools did not exist for it to do the right thing. And unfortunately for these companies, they've already set down a path that they can't really correct. But that's why Grass exists. Grass's intention, it isn't necessarily to go and become this better alternative to these companies. It's to go out there and replace them in the first place. We have a very unique advantage right now, where by cutting out all the middlemen, all the value extractors, we as a collective are actually capable of producing tools that are A, more efficient and more powerful, and B, just doing the right thing. And we can actually make the internet a better place for everyone. Now, to the meat of the presentation, what's live context retrieval? Talked a little bit about how models are only as good as the data that they have access to, and how new data will always be present on the internet. Now, think about an LLM being used by any enterprise or anyone in the world. How useful is it if it doesn't know information that just happened this morning or last night or a week ago? How useful is an LLM that was only trained up until data that existed like a few months ago? It's not actually that useful. Now, for any enterprise use case, like think about it, all the Fortune 500 companies in the world, they'll eventually be using LLM technology. Many of them already are. And how useful are their use cases if they can't actually see what's happening in real time? It's not really that useful. And you might ask yourself, okay, well, why don't they just get their servers to go and use these live browsing features that some of the LLMs are beginning to offer? These live browsing features, they're powered by what are called knowledge graphs, which are these mathematical constructs that were derived from internet scale web crawls. And these web crawls can only be done by two companies in existence right now. Those companies are Google and Bing. And that's why OpenAI and Google have this asymmetric advantage when it comes to offering any sort of real-time insight. Now, the problem with what they're doing is, beyond the whole monopolistic nature of it, the problem with what they're doing is the fact that they get to decide what's showing up in these live feeds of data. So if you think about, getting an LLM to actually answer a question with real-time information, there's only two sources that'll allow that LLM to connect to the internet and give you the information that you're asking for. Now, think about the two companies behind those two sources. Do you actually trust them to guide you and your interaction with a world in which all your interactions are with an LLM? The answer is most likely not. And when you think about what Grass does, it's actually a pretty powerful concept. The fact that when you ask a question to an LLM, or when you prompt it, or when you get it to do anything, and it needs real-time information, it routes that prompt through millions of nodes around the world. connects to a knowledge graph of the entire internet that's been created by Grass and extracts the information that it needs in an unbiased way while producing proofs of those web requests that anyone can see, anyone can acknowledge, and no one can dispute. And all the while, every relevant stakeholder is being properly compensated for this. A lot of people here in the Discord, they've been complaining a bit about, things like airdrop one and like, I totally get that. I hear everyone here, but that's not the point of Grass. The point of Grass is you're running a node. When LCR is live, when there are thousands of LLMs around the world prompting the internet, trying to extract things from the web, and your node is part of the engine that's powering this, um, you get to actually monetize your bandwidth. Like that's the point of this protocol. The airdrop is more of a bonus, and I go thank you for everyone here for being early. And trust me, everyone here is very, very early to what we're building. Now, another advantage that's a bit more technical when it comes to LCR is the fact that by routing this information through millions of web requests, web servers don't actually know where that web request is coming from. So like beyond anonymization, you also have the opportunity to be censor resistant. No one gets to decide other than you, like whoever's using this tool, what's actually being prompted, like what real-time data is actually being retrieved. Now, the reason it's called live context retrieval is because instead of focusing on, shoving as much training data into a model as possible and trying to make it like slightly better that way, or trying to figure out which huge training corpus is going to be used to fine tune a model, live context retrieval actually allows you to go and scrape that data and add it to the context window of the model. Like that's where your prompt goes in. It adds this new live context to the prompt, and then it goes into the model afterwards. And then the model can actually make much better decisions that way. Some of you are in our Telegram. I've actually shared a couple of papers in there that have shown that prompting models this way, like through methods such as live context retrieval, actually reduces hallucinations. Hallucinations, as many of you know, are like one of the biggest issues with models right now. And one of the best ways that we know right now, like they are kind of a necessary evil, but one of the best ways to actually reduce them is to guide the model a bit along the right path. And there's no better way to really guide it along a proper path than to give it access to real-time data, data that hasn't existed anywhere else in the world up until this second. So, who here knows who this is? Drop it in the chat. Yeah, it's Alice. Our good friends over at Lion, the foundation behind Stable Diffusion, they published a paper not too long ago called Alice in Wonderland, where they evaluated a ton of the models that were claiming that they can reason and giving them very simple problems. They called it the Alice in Wonderland problem. Very simple word problems that a grade school student could solve. And these models failed. However, on all the massive reasoning benchmarks, these models were scoring 90% plus. Completely debunked a lot of these, like, these models can reason properly theories. Now, one of the most interesting insights that came from researchers after this paper got published was when they tried to recreate the study. They showed that, yeah, indeed, when you prompt a model with this Alice in Wonderland paper, with this Alice in Wonderland problem, it'll break down, it'll give you the wrong answer. However, if you take an online model, like one that's actually connected to the internet, and give it this Alice in Wonderland problem, it somehow manages to solve it. Now you can ask yourself, how on earth is a model like suddenly capable of reasoning if you plug it into the internet? And it's a great question. And it's a great question because the answer is it can't. It's not actually reasoning. However, it performs better at reasoning problems when you give it up-to-date information. Because most of the data that's being pushed onto the internet is either created by a human or has been created because a human got a machine to create that data. And humans are, the only organism right now that's actually capable of reasoning. So most of the data that's appearing on the internet gives the impression of reasoning. And sometimes that's all it takes for a model to actually solve a problem. And in 99% of cases, no one really cares how the problem is being solved. It's just the fact that the problem is being solved in the first place. And connecting a model to the internet happens to do that. And it's such a simple concept if you think about it, but very, very difficult to implement. And grass is actually the only way to do it properly. And like it's one of those things where look at ChatGPT and like O1 right now. Look at all the cool things that people are doing with it. Imagine, it takes what, 20, 30 seconds to think about something. LCR takes 0.5 seconds to query anything on the internet. Imagine you take a model with the capabilities, the deep learning capabilities, like the ones that just got produced last week, and you plug it into LCR. The possibilities are almost endless. Like it's part of the reason why this is one of the most exciting fields, in my opinion, in all of AI, is live context retrieval. And I want to talk a bit about Grass network effects. I put out a tweet last week saying we crossed 40 terabytes in daily data scraped. Now that's over 60 terabytes. Um, and the interesting thing, I talked a bit earlier about how a lot of these models, like 2 years ago, it was kind of a race to brute force these things. Stick as many parameters and like data as you can into them. Hopefully they'll perform a bit better. A lot of companies are being a bit smarter these days. They're trying to do more with less compute, which is the smart thing to do, which we agree with. But there's one area of AI where we haven't really hit saturation yet, where we still need loads and loads and loads of data. And that's in multimodal data, multimodal models. And it's our view that this field hasn't even exploded yet. Like in the next 2 years, one of the bigger aspects of AI, like one of the biggest things popping up in AI, is actually going to be in the field of generative models, whether it's voice or video. And we're seeing this firsthand right now. Like a number of like Grass usage has been turned on like in the last few months, and it's hitting these ridiculous numbers. And the majority of that 60 terabytes in daily volume is coming from multimodal needs. Now, yeah, this slide, I guess, like I went a bit off course, but like this slide is actually about what Grass is capable of. So these 2 million nodes today, they're scraping 60 terabytes of data daily. Now at 20 million nodes, in theory, we should be capable of scraping enough data to train ChatGPT 3.5 from scratch on a weekly basis. Now, some of you might be wondering, isn't 3.5 trained on about 45 terabytes of data, and isn't Grass doing 60 terabytes daily? The answer is yes. So actually, Grass is already capable of doing this. Grass is already scraping enough data, like on a terabyte basis per day, to actually train ChatGPT from scratch on a daily basis. Now, what we mean by saying on a weekly basis, like, it would be able to do it by week. As many of you know, multimodal data takes up a lot more bandwidth than text data, and it's about 20 times more. So if you convert that 60 terabytes a day to text data, you end up seeing something a bit more linear from the 2 million to the 20 million. And I alluded a little bit earlier to an internet scale web crawl. And that's the point at which LCR actually becomes unstoppable. We talked a little bit about Grass as this like unstoppable data layer, this network that's coordinated by millions and millions of people globally who are joining it and allowing any model to have online capability in real time and being able to get compensated for it. At 100 million nodes, like this becomes very, very real. And at that point, you're actually, you're looking at things like Google, and you're looking at things like Grass. And then a system like Grass that's being powered by the majority of online devices in the world actually ends up becoming a more efficient system than systems like Google. And that's our end goal. Like we're not in this game, like we're not working on Grass because we really, like for 60 terabytes a day, it's really exciting. But that's not really what we're here for. Like we're here for the internet scale web crawl. That's what we're really excited about. Now, speaking of internet scale web crawls, like what do you do with one? When you crawl the entire internet, you actually have to connect all this data, like all this information from around the world. The way you do that is through a knowledge graph. Like, it's been shown actually in recent studies that. Sorry, I'm just looking at the chat. Some of you guys are pretty funny. It's been shown in recent studies that when you prompt an LLM and give it information from outside the LLM using a knowledge graph, as opposed to something more traditional like a vector database with cosine similarity or whatever, you actually get 12% better improvement. And 12% might not sound like much, but when you think about 100 million different LLMs being prompted at the same time, 12% is a huge deal. And it is the way forward. When you're adding any data to a model that doesn't exist in the model yet, during the prompting process, it needs to be done through a knowledge graph. And if you can think of graphs as end goal, really to be a knowledge graph of the entire internet. And the way these things work is like you have a bunch of different semantic knowledge, right? So like in this example here, you've got Bob who's interested in the Mona Lisa, and he's a friend of Alice, and he is a person. You have all these different facts that are connected to each other in a graph. Now you think about all the information on the internet in a huge multi-dimensional graph. Like that's what Grass is building right now. And by running your Grass node, like that's what you're contributing to. And at the moment, there's no system like this that is actually open, that anyone in the world can take part in. So anyhow, I talked a bit about UpvoteWeb earlier. It's a huge data set that Grass put out recently. And Grass will be putting out an even bigger one that's a bit more impressive soon. So stay tuned for that. And yeah, that's LCR. Hopefully that's a bit of added context a lot of people were asking for, and now I'd be more than happy to answer any questions.
Awesome. Feel free to drop some questions in chat, guys. Sweet. Okay. Okay, I got your question, D gentleman.
It's a good user.
Okay. I caught a question from earlier. You good to go, Dre?
Yeah, good to go.
Sweet. So one of the questions was if upvote web took Grass a week to scrape, how quickly could it be done again in Grass's current state?
Yeah, a number of optimizations have been made, probably less than a day.
Yeah. That was a great question, Thrillos. Next question's from Binary. Will training models with larger data sets take more time, and can companies do that faster?
Absolutely. So when you say faster, I'm assuming the question is like, would they do it faster with Grass, or in general?
I think in general.
In general, yeah. I mean, these things are getting faster and faster. Like every 2 years, like the size of these chips halves. Um, Compute gets more powerful, more data becomes more available. Uh, I mean, right now, like for the time being, with the current architecture of models, there's no serious need to make them much bigger than they currently are. The way, like, we're starting to see like diminishing returns from making models bigger. At their current maximum size, if you were to make them 10 times larger, you'd be bankrupting companies in order to get the compute to actually train those models. And they wouldn't actually be that much better. So, and you can think of this as like logarithmic improvement. So like when ChatGPT 3, like when GPT 3 came out, it was trained on 100 times more parameters, compute, and data than GPT 2. And the output was ridiculously better. Now, to get the same output, you'd have to 10,000x. And then from there, you'd have to 1 millionx the amount of data parameters and compute. And at a certain point as well, like all these models are really doing is predicting the next word in a sentence. So how much better can it really get at that if you think about it? And you're starting to see a trend now away from building larger models faster, but just building smaller models that are smarter. GPT O1 is like a great example of this new trend. They said, okay, well, we've gone the best we can with language reasoning. 4.0 is just as good, if not like a bit worse than Llama and Claude and all these other models that have kind of caught up when it comes to language reasoning. Where can improvements still happen? And it's areas where reinforcement learning can be implemented. So coding and math reasoning. And you can actually see, if I get some of the more recent results, the difference between O1 mini and O1 preview is not that different, but one of them's like 10 times cheaper to run than the other one. And what that really tells you is that the improvement isn't happening in the parameters and in the pre-training. It's happening in that chain of thought process. So it's really good for inference, and it's really good for anyone working on like real time, such as Grass. But it's not that great for like large, I guess, large companies that are really dependent on huge models continuing to gobble up massive amounts of compute. So when you're looking at O1 Mini and O1 Preview, and they have like very similar performance when it comes to mathematical reasoning, there's no reason to use O1 Preview. Uh, and yeah, actually, like one of the interesting things too, and like I know this isn't an answer to the question, but beyond that, I think it's interesting to note uh, the fact that all these like chain of thought models that are coming out all of a sudden are slightly worse at language reasoning than the original models, but like much better at things like coding and arithmetic and symbolic reasoning. But they're still worse than symbolic NLP methods that existed 20 years ago. So you got to start asking yourself, like, it's kind of ironic to invest trillions of multiplications into training a model that cannot multiply two huge numbers together. Like it is ironic, right? And I think the direction that a lot of these models are actually going to go moving forward is figuring out how do you translate the modality of like text and like your traditional LLM to that of something that's more NLP, like old school NLP and symbolic focused. And it's more going to be about having a bunch of different methods, like different frameworks that are able to connect to each other and flawlessly communicate with one another, as opposed to just brute forcing like huge transformer models. So, yeah.
Awesome. That was a great question, Binary. And thanks, Andre. Moving to the next question from Twin Peaks. Um, how does an LLM connected to the internet know where to find accurate data with so much new information being uploaded all the time?
Yeah. So that's where the web scale knowledge graph actually comes in. When you do a crawl of the whole internet, you're indexing it. And when you connect all that knowledge together into a knowledge graph, the process of knowing where to search actually starts with the prompt. So LCR will receive the prompt. And then given the words in that prompt, it will know where along that knowledge graph to search. And it'll find like this minimum distance that it needs to hop to give you the answer that you need. And then based on that index, it'll know exactly what website to scrape in real time. All of that happens in about 500 milliseconds.
Awesome. Okay, moving on to the next question. Um, are there existing, let me see. Okay. Are there existing centralized solutions that are capable of real-time inference? How much cheaper is achieving real-time inference with Grass's decentralized network than it would be with an existing solution if they exist?
Yeah, that's a great question. So yeah, as I mentioned earlier, there are solutions that exist right now for just real-time data retrieval. They don't, I'd say they aren't as efficient as they could be. Um, so you have these pre-existing knowledge graphs, such as Google's and such as Bing's, that are being used in, for example, OpenAI's models and also in Gemini's models. Uh, when it like when you're prompting them, um, most websites like, they'll see the IP address of the OpenAI servers, or like the Google servers, and if that website doesn't want its data to be used in AI, it'll block it. If that prompt is being routed through something like LCR, it's unblockable. And for that reason, you can actually end up charging the same amount as these existing companies and capturing all of the demand because Grass actually offers something that they're incapable of. Like Bing doesn't have access to a network of millions of nodes that people opted into and said, hey, like I'm gonna leverage some of my bandwidth to help in this initiative. Like that just doesn't exist anywhere else other than Grass. So yeah, it is a great question. Like there are solutions right now. They are fundamentally flawed. And when LCR is launched, I struggle to understand how they're going to stand a chance, honestly.
Awesome. That was a great question. I think that was Jeeves. Um, Sweet. The next question comes from N8. I think this was similar to, well, yeah, why is training even needed? Can't training happen in real time?
Uh, can training happen in real time? Not, I mean, you can do that. It would be very expensive and pretty inefficient. Um, I, so if you think about language models and what they're really doing, like they receive a bunch of words, they turn those words into numbers, and then they just do a bunch of math with those numbers to spit out new words. And the math that happens in the middle, it's not that different from the math that you did in grade school when you have a bunch of different dots and you have to draw the line of best fit. That's basically like in a very simplified way what these models are doing. Now, imagine you have this line of best fit, and as you're using the model, like that line keeps adjusting. Like after a certain point, like it'll stop moving because so much data went in and because the patterns were all found. And at that point, you're just wasting money on compute. Now that's the case for like the traditional sense of these models. Now, when you ask about real time training, in a different way, like that's kind of happening. So every time you speak to one of these models, like every time you use OpenAI's ChatGPT, or every time you use Claude or any of these other like, providers of LLMs, they're actually storing all of your chat logs internally and then using them to retrain the model. So there's a certain level of reinforcement learning that happens. Like with all of like, everything that you tell the model, they store it on their servers and then they go and reuse it to retrain them. But that isn't necessarily real-time training. It's just like real-time collection of data in order to train the model. And it's a lot more efficient to just have a model that's already trained, it's already capable of doing what you need it to do, and then just give it the new information that it needs to go and answer the questions that you need.
Awesome. That was a great question. And I just looking through some of the other questions. Um, Question about LCR. Could LCR be used in the financial industry to provide this data fast for things like algorithmic trading?
Absolutely, yeah, absolutely. We're actually the foundation I'm hearing is getting ridiculous amounts of inbound from institutions that are looking to do that.
Sweet. I didn't see who dropped that question, but great question. Um, Next question is, what infrastructure are you using to support the um, attribution of data back to its contributors? Is this something built in-house?
Yeah. So this is all built in house, and keep an eye out. There will be a lot more news on this. Brass has some really cool things in store in that field. Not much I can really speak to at the moment, but it's probably one of the things I'm very like probably one of the things I'm the most excited about actually.
Awesome. Great question. Uh, yes, I'm gonna drop you our docs.
All right, I think maybe we can ask you guys a question. This was a presentation that was made a few weeks ago for a separate event, and like some of the data in there. I wouldn't say like some of the facts in there are outdated, but it isn't as current with the times. Some of the anecdotes that were shared in the presentation. We're thinking about doing a few more of these where we can just hop on camera, talk to the community, like present a few things about grass. Is there anything in particular that you guys want to hear a bit more about? You can just drop in the chat right now. Okay, people are saying tokenomics. That does not need a presentation. Um, you can just watch the official X account.
Data provenance. What else? Merch. Merch is coming.
All right. What do you guys think? Should we call it a night?
Looking through the chat.
Yeah, one of these days we're gonna have to hop on Discord and actually just do a demo of LCR for everyone. Um, I think people love to see that. Yeah, how about that? When it comes out of alpha testing, the first place LCR will be shown is going to be here in Discord.
I think people are pleased with that.
Yeah, okay. I agree.
And yeah, I mean, I guess if you guys have any other ideas on what you want to hear about, um, just drop it in general. Yes, you're right. And a suggestion channel needed. Yeah, I could spin that up.
Yeah, that's a good idea.
Let's do that. Okay.
Oh, actually,
Yeah.
someone in the community just asked a pretty good question. Binary. Um, these companies have billions of dollars of hardware. They can do it really quickly in a data center. Um, yeah, so this is actually this is a great question because in crypto right now, you're seeing probably 99% of protocols out there who are building peer-to-peer systems. And you kind of ask yourself, when do you really need peer-to-peer? Because most of the time, having something peer-to-peer actually makes it slower. When you have, millions of nodes that have to coordinate with one another, it's obviously a lot slower than having a ton of hardware sitting in one data center. Uh, Now, there are some systems that benefit from being distributed, and others where if you distribute them, you're kind of just wasting everyone's time. Now, Grass is obviously one of those systems that benefits from being distributed. How else can you get literally millions of devices with individual residential IP addresses? You can't really build that in a data center. It doesn't matter how much hardware a company has and how much money they have. That's not something that they're capable of doing. And that's like a very, very key competitive advantage to Grass. Um, Now, yeah, I guess uh, a few folks in the community have actually been asking me a bit about storage recently. Um, Storage is one of those things where, yeah, Grass is actually scraping ridiculous amounts of data. Grass needs to store that data somewhere. And people ask me about like distributed storage solutions, like decentralized storage. You end up running into a lot of issues. Like, what if someone turns off their computer and the data that you need is stored on that computer? Or what if some person decides they don't want something stored on that device anymore? You don't really have control of it. And that's one of those examples where, to your point, Binary, like a company can have billions of dollars and just invest in a ton of data center infrastructure, and it's very hard to compete if you're a distributed system. But Grass is a bit the opposite there. And Binary, to answer your other question, this is already happening on about 90% of networks today. Uh, there are companies out there, middleware companies, that are putting SDKs into like your free VPN or your free screensaver. Well, on most of the Roku TV apps, really, are doing this right now, and they're selling that bandwidth to large institutions without compensating you. So you asked about risk, like this is already happening, and Grass is more about taking back that control and stopping them from, just starving them of that opportunity. Toblerones, is there not possibility in the future that we could control? Yeah, yeah. So like, especially after the Android application comes out, users will have the ability to limit, the amount of bandwidth that can be scraped on their device, and secondly, um, they'll be able to limit what sources or what websites can be scraped. Like, that's definitely something that's on the roadmap. What would I like to say about the Buds NFT is a question. The Buds NFT are a visual representation of a community. They're a very important part of the community. And that's what I've got to say about it right now. And if you ask me about utility, I'll just say what I've been saying. No utility, Grass only. Good question about the hat. Merch store is going live soon.
My mic was muted the whole time. I was just going to say, if you want to check out Grass, you can go to discord.gg/getgrass. Um, and that I figured I'd call it early there because I got some other stuff to do. But if and when they do an LCR demo, I will definitely try to grab that and catch that because I think that'll actually be interesting. Okay, that's it.